Hello friends, welcome back to BreathFX program, Inside Fellowship program in Advanced Analytical Problem Solving Expertise. And we are going to continue with where we left last time in last video. We were understanding P charts, and as we promised, as we discussed in the current video, we're going to go ahead and understand how to plot a P chart. So for that sake, let's go to next slide. So this is where we left last video, control phase data collection, the way we collected data for measure phase and improve phase. Likewise, we are going to collect data for control phase as well. Why we want to collect data for control phase? Of course, we want to prove or we want to validate that improvement sustenance has occurred. And we have to confirm that there is an improvement with the help of capability analysis. So for both of these assessments, we need to collect some sort of data. The difference between measure phase data and improve phase data is, we can collect data for more number of days in control phase. And as we discussed, we collected data almost for 6 to 7 different weeks. So on that note, let's recap where we left last time. So process manager supposed to share the data of project Y for next 6 to 7 weeks with Greenbelt project leader, that is you. Each week will have approximately 18 shifts. It process is working in 3 shifts per day. Greenbelt project leader need to plot a control chart for 6 to 7 weeks data of project Y. In case of current case study, process managers share the control phase data of average processing time for each shift for next 6 to 7 weeks with Greenbelt. GB converted average processing time per shift into PT compliance, that is C, which is less than 270 seconds. If average processing time per unit for a given shift is less than 270 seconds, then that is compliance shift. Or it would be non-compliance shift if average processing time per unit for a given shift is more than 270 seconds. So likewise, there will be 6 to 7 data points, one for each week. Each data point is a proportion of number of non-compliance shifts in that week divided by total number of shifts in the same week. So this is where we left last time. Let's go ahead. Right, so this is the control phase data. We started collecting data on 22nd of March 2022. So this is the same thing, right? Same pattern or same template. Phase, week, day, then shift, number of units processed per shift, total number of total time available in a given shift. So that is 288,000 seconds. Then average processing time per unit for a given shift. And of course, based on these numbers, we're going to have a PT non-compliance, right? So likewise, we have collected data in a control phase till 2nd of May 2022, right? Now, what to do with this particular data? So we would use this data and we are going to plot a P chart, right? And we're going to plot the P chart into statistical tool of BreathFX, right? So that's our own statistical tool. We are not going to use any other statistical tool, which will be quite costlier to buy, and of course quite tedious to use for that matter. So this is the simplest possible tool with the same accuracy, and this is ours, so you can use it. So use control phase data from previous 3 slides to plot control chart, that is P chart. From previous 3 slides, copy data for column of phase, date, PT non-compliance, and paste it in our tool of P chart. Ensure to check data of phase column is in capital letters and there is no space bar clicked after typing word control. So please do read it as a P chart. It's not a P, right? So let me make that correction right in front of you. Right, so that will not have for P chart, right? So let me read those instructions again. I'm going to save it over here. This happens bit here and there, so some typo errors. Right. So use control phase data from previous 3 slides to plot control chart, that is P chart. From previous 3 slides, copy data for column of phase, date, and PT non-compliance and paste it in our tool of P chart. So this is what data we had, right? So we need to copy this column, then this column. This is the date column. This is a phase column, right? Let me use the marker so it will be easier. A pointer, sorry. So this data we are going to use. Then we are going to use this data, this column, and finally we're going to take this column. These 3 columns we need to take, and all we need to do is we need to just copy them into our tool of P chart. But meanwhile, we got to ensure that I mean, for phase columns, we are going to write the given phase, control phase. All the letters supposed to be in a capital letters, and there is no space bar click after typing word control. Why? Because as we told you last time that system, if we have any space after the word control, system will pick that as a control plus space together, and then system will not consider this as the word of control, right? So that's the nitty-gritties of the system. So requesting you all to ensure that there is no space bar, click after typing the word control, and this word supposed to be typed in a capital letters. So let's go to next slide and see how we're going to plot the P chart. This is the data we have, where we have copied column of phase, then column of date, and then column of project Y, right? That is PT non-compliance, and we're going to paste it over here. Once we pasted it, we got this particular P chart. So this is a control phase P chart. This is what, and this is how it will look, P chart. So control chart, number of days with PT non-compliance in a week to total number of working days per week, right? So each of this point, and this point, third point, fourth, fifth, sixth, and seventh, all these are proportions. Proportions of what? Proportions of number of defective shifts in that particular week divided by total number of shifts in a given week. Again, number of defective shifts in that week divided by total number of shifts in that particular week. Likewise, we'll have 7 different proportions, and we're going to plot it. So you could see this is the central line, this is the upper control limit for each point, and this is the lower control limit, the yellow bar, right? So yellow bar, then amber bar, and then black bar, and of course the gray bar. That is your central line. So this is the P chart. So interpretation based on P chart, we can conclude that all data points are within upper and lower control limits. All data points are within these upper and lower control limits. This indicates that process is under control. This is what we're going to indicate. This is our interpretation as well as our inference. So I guess as we promised or as we discussed, we're going to have live case. We're going to take it and we're going to take the live case, the same data, and we'll show you how to plot it. So please give us some time, maybe in a couple of seconds. So I'll just adjust to the Excel. Let me check. Right. So this is what a data we have in Excel. Right, the same template, the way we use it for improve phase as well as measure phase, week, day, shift, number of units processed per shift, total time available in shift, then total processing time per shift, and PT non-compliant. This is for a control phase data. And then we have collected this data for almost 6 to 7 weeks, right? So all we're supposed to do is we need to, yes, this as well, right? So we need to take this column, then this column, and then this column. So let me try it this way. This column, then I'm going to collect this column, wait, this, then I'm going to collect this column, and of course this column. These three columns I'm going to pick, and then I'm going to paste it over here. So I pasted it and I got three different columns over here. So all we need to do is to just copy these numbers. So I'm going to just copy it from here. This is what I'm going to do live in front of you. This is what this is what I'm going to pick all this data points, and I'm going to just right click it, copy it, and then I'm going to go to our tool, control chart tool, and I'm going to just paste it over here. So I have pasted it over here. So let me do it again, right click and paste it. So I pasted the data over here. And once I pasted the data, this is what a graph I got. The same graph we have seen on a deck or in a presentation. Same graph is here. Here we have our upper control limit. Here we have lower control limit. These are the data points we already discussed. And of course, this is our center line, right? So let's try it again. First of all, I'll just remove these data points. There will be no any confusion. I have removed this data point. You see, it's vanished, right? So this is these are the blank columns. Now let's go back to our Excel of PT non-compliance data. And from here, of course, as we discussed, we are going to select and pick this column. Then we're going to pick this column, and then we're going to pick this column. We're going to copy it, and we're going to paste it over here, which we already did, right? Once that is done, then we will select this data. We'll not select the title, by the way, right? We'll select just the data. Right, so we are selecting the data over here. We have selected the data. Right click, we are going to copy it. Once copied it, we are going to go back to our control chart. Right, this is blank now. So right click and paste it. Once we paste it, this is where we got our control chart. So control chart of control phase, which is a P chart, right? So this is what we got. And from here, we took a print screen or snapshot and pasted it in a deck. So this is what we supposed to do. This is how we're supposed to plot the P chart. It's a very easy, as simple as that. So on that note, let's get back to our deck. So this is what the snapshot of what we just now did. And the interpretation or inferences, based on P chart, we can conclude that all data points are within upper control limit and lower control limits. This indicates that the process is under control. On that note, let's move to the next slide. Right, so control phase contingency management. So once we plotted the control chart, that is P chart, now we got to look into control phase contingency management. Now, what is contingency management? Right, so if in case any data point goes beyond control limits for any week, Greenbelt, that is you, need to investigate this unusualness and check with the process or operations manager whether control plan is properly followed or not. That is the first thing you need to check. This is rare, but if issue that causes unusualness has not been occurred previously, and if not maintained previously in cause log during major phase or even improve phase as well, right? Find out possible causes for the issue and fix it with the solutions. Then ask operations manager to update cause and solutions log and control plan with new causes, these causes or these issues and their solution, these issues solutions also. So that we'll have updated cause and solutions log. By the end of 6 to 7 weeks, validate sustenance of improvement and calculate sigma value. This is what we're going to do under contingency management. So if any data point will go beyond the control limit, so what to do in that case? When we plot P chart in our current case, not a single data point went beyond the control limit. But what if any data point for any other project goes beyond the control limit? What needs to be taken care of? So this is what we have discussed right now. Let's move to the next slide. It's a quiz time. SPC is an early warning system that alert when project Y go out of control. True or false? And the answer is true. Answer is true. Next question. Control chart is like line chart, but with the addition of control limit lines, upper control limit and lower control limit, and an average or center line. Center line. So is this right or wrong? Is this true or false? And the answer is true. Control line or control chart is like line chart, but with the addition of control limit lines, that is upper control limit and lower control limits, and an average or center line. It's true. Next question. Control limits are typically set at approximately length from the center line. 3 standard deviation, 2 standard deviation, or 1 standard deviations. And the answer is 3 standard deviations. So control limits are typically set at approximately 3 standard deviations from the center line. Next question. Specification limits, that is USL and LSL, appear on control charts. True or false? And the answer is false. There is no specification limits on a control charts. We will always have control limits, and control limits and specification limits are different. They are not same. So specification limits appear on control charts. Is it true or false? It's false statement. Next question. We plot proportion of defectives, that is number of defective units in a sample divided by uneven number of units collected in a sample with control chart called P chart or NP chart. And the answer is P chart. So we plot proportion of defectives with control chart called P chart. Next question. If in P chart any data point goes beyond control limits for any week, Greenbelt need to investigate this unusualness in contingency management. And the answer is true or false? Answer is true. If in P chart any data point goes beyond control limits for any week, Greenbelt need to investigate this unusualness. On that note, we are almost done with this particular aspect called control chart or P chart. So we are done with define phase, then measure phase, then analyze phase, then improve phase. Then we are done with developing control plan, then collecting data for project Y, and of course we are also done with how to plot P chart, right? So in upcoming video, we are going to compare, improve phase project Y with that of control phase project Y. Why are we going to compare this? Because we want to prove and validate that improvement is sustained or improvement is stabilized into control phase. And we're going to use 2P tests for the same, to validate the improvement sustenance or improvement stability. So I guess we are going to look into this in the upcoming video. So for time being, I would like to thank you all for being around with us, and requesting you all to please let everyone know about our program, Breakup Its program, and let everyone get benefited out of it. So on that particular note, Uttishta Bharata, Ma Bharati shall rise again in her full glory. So before we end today's session, let's thank technology companies for their technological support. Meanwhile, if you like the video, please click on like button. Please share it with your friends, family, relatives, neighbors, and network. And if you have not subscribed our channel, please do channel our Breath Affects Families YouTube channel. On that note, thank you so very much, and let's meet up in the next video. Thanks a lot.